Hello. Today you're going to be taking notes on a box and whisker plot. A box and whisker plot, so you're going to write down everything that I have written on my screen in your notebook in part 5 on page 3 or 4. So a box and whisker plot. A box and whisker plot is a way to display a set of data by dividing the data values into 4 parts, which are called quartiles, and graphing the 5 most important parts, and that's called the 5-number summary. So please copy that down. Pause the video. Now that you've gotten this definition copied down, I need you to copy down this set of numbers. Pause the video. So when the first thing that you're going to be doing when you're doing a box and whisker plot is that you are going to be organizing your data in ascending order. So number 1, we want to put our data in ascending order. So do that now. Make sure you copy down this step. The second thing we're going to do is once our data is in ascending order, we're going to find the 5-number summary. So we are looking for 5 key numbers that will help me to identify things about this data. So we're looking for the 5-number summary. So the 5-number summary, you're going to do it differently. The first thing you're going to do is you're going to draw a circle around the least value in the data. So draw a circle around the lowest number, okay, which of course is our 8. That circle represents the minimum or lower extreme of our data. So underneath the 8, please draw an arrow and write lower extreme or minimum. So that's our first number in our 5-number summary. The second thing we're going to do is we're going to draw a circle around the greatest value. So draw a circle around the 50. And the 50 is called the maximum. Oops, sorry. The 50 is called the maximum or the upper extreme. So please label that. Oops. Okay. All right, so far we've found 2 of our 5 numbers. We've got the lowest number, which is the minimum or lower extreme, and the highest number, which is the maximum or the upper extreme. The third number that you're going to find is the median. So the median is the middle piece of data in a set of data that's been written in ascending order. And so I'm going to look at my data set and I'm going to try and find the middle number. So I'm going to count off. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So that means that 8 goes with 50, 10 goes with 40, 12 goes with 32, 21 goes with 25, 22 goes with 23. So the median is going to fall between 22 and 23. So this is easy. I know that halfway between 22 and 23 is 22 and a half. If I didn't know that halfway between those 2 numbers was that number, I would find the average of those 2 numbers. So I would say 22 plus 23, that's 45. And 45, of course, divided by 2 is 22 and a half. So 22 and a half is my median. I am going to draw a vertical line representing where my median would be in my data set. Now, because my median is not a part of my data set, the vertical line is going to fall between these 2 numbers. Okay, so draw a vertical line right there. And then above that vertical line, we're going to write the median. So I'm going to put my 22 and a half right there. So I know when I look at this data set that the lowest number is 8, the highest number is 50, and the middle number is 22 and a half. So far I've found 3 of my 5 numbers in my 5-number summary. All right, so now I'm going to find the next term, the next number that I need, and the next number I need is the lower median, okay, also known as quartile 1 or the lower quartile. The median is known as quartile 2, and if there are 2 middle numbers, it's the average. So the median can also be called quartile 2, just like the minimum can be called the lower extreme and the maximum can be called the upper extreme. So the lower median, well, it's a median of the lower part of the data. So the median divided my data in half. So I'm going to look here at this bottom half of the data and find the middle number of the bottom half of the data. So I find the median and the low numbers. So 8 and 22, 12, 10, and 21. So the median of this data is 12. So since my median is part of my data set, I'm going to draw a vertical line directly through that 12. So that vertical line indicates that it's a median. See, we've got a median, we've got a median, we've got vertical lines. We've got a minimum and we've got a maximum. Those are circled. Notice when I found the middle of it, I included the 8. Just because the 8's circled doesn't mean that it's not part of the data set. It is. So I'm going to go through here. I've got 22, crossed off with 8, 21, crossed off with 10. So the median, the lower median, is 12. Okay, so that lower median, it is 12. Okay, the last thing that I'm going to be finding is I'm going to be finding the upper median. So the upper median, so thinking about what we just did, the upper median is going to be the middle of the upper part of the data. Another name for it is quartile 3, or the upper quartile. So once again, I go to the upper half of the data. See, here was my original median, and I'm going to look for the middle of these 5 numbers. So I've got 23 and 50, 25 and 40. So the middle number is 32. So once again, I draw a vertical line right straight down through that number. So let's take a look at our data. All right, so that is my upper median. So my 5-number summary consists of the following pieces of data. It is 8 for my minimum, 12 for my quartile 1, 22.5 for my quartile 2, 32 for my quartile 3, and 50 for my maximum. All right, so that's my 5-number summary. These 5 numbers tell me about this set of data. All right, so what does it tell me? Well, let's look at the data. So the data is here, and you'll notice the vertical lines. And what happened was when I drew this vertical line, in this part of the data, I have 1.5 numbers. In this part of the data, I have 1.5 numbers. In this part of the data, I have 1.5 numbers. And in this part of the data, I have 1.5 numbers. So by drawing these lines this way, I've effectively cut this data into 4 parts, hence the name quartile. So when you're cutting your data into 4 equal groups, each of those groups is called a quartile. So this piece right here is Q1, quartile 1. So it's the first quartile. This is quartile 2, the second quartile. This is quartile 3, the third quartile. So this is the first piece of data, separated from the next group by quartile 1. This is the second group of data, separated by quartile 2. The third group of data, separated by quartile 3. So now, how do you show somebody these numbers, and how do you do this? So I've got a number line down here at the bottom. And so I need to be able to put these 5 numbers on this number line so that someone who looked at it would be able to determine different things about this. So I could just put the numbers on a number line, 8, 12, 22.5, 32, and 50, but that doesn't tell me about where the numbers would fall on the number line. So I need to think about how am I going to divide up this number line so that somebody could really see that 8 to 50, that was a pretty good distance, because if I just put them 8, 12, 22.5, 32, and 50, that's not an accurate representation. So that would be a line of numbers versus a number line. So I'm going to number off my number line. My lowest number is 8. My highest number is 50. So I think I'll count by 5s. So I'm just going to real quickly put in the 5s for you. Okay, so I've got my number line set up, and I decided to count by 5s, but I left these spaces here so my number line wouldn't be all smashed up. And so now I'm going to put my numbers on my number line. So if I look here at my 8, that's surrounded by a circle. So the first number that you put on your box plot when you're doing it is the lower extreme. And to indicate that, the way you make a lower extreme is that you just put a single dot. So above the 8, so this is 5, this is 10, so 8's going to be about here. So I'm going to put an 8 dot right there. Now, because it doesn't say 8, I have to write the number 8 above it so that there's no confusion as to what that dot represents. So I've got an 8 right there, and I'm putting it there because it's not on my number line below. The next piece of data that I'm going to put on my number line is the 55, or the 50. So I'm going to go here, and I'm going to put a dot right here. And I'm putting the dot right there above the 50. I don't need to mark that unless I'd really like to. You can, of course, so I'll put the 50 there just so there's no confusion about what that number is, but it's pretty clear when it's actually a number that lines up with the number line, but we'll just make it so that we can really tell what our numbers are. Okay, so I've got my minimum, I've got my maximum, I've marked those with dots. Notice that I marked all my media, that's a plural for medians, all my media with vertical lines. So I'm going to use vertical lines to mark those numbers on my number line. So I'm just going to go back here. Where are my lines? Oh, there. Okay, and I'm going to make a vertical line at 12, and I'll come back and number these later. So I get a vertical line here at 12, and then I'm going to put a vertical line at 22 and a half, and then I'm going to put a vertical line at 32. Okay, and I'll put my numbers in. So I'm going to look at my box and whisker plot. So now I've got my 8, I've got my 12, I've got my 22 and a half, I've got my 32, and I've got my 50. That's my 5-number summary. So the name of this is called a box and whisker plot. So the reason it's called a box and whisker plot is because you connect the medians using a horizontal line, and that creates a box. And mine's a little wonky, but you get the idea. So that's my box. And then the whiskers are the distance from each of the upper and lower quartile out to the dot. So remember, this shows me all of my data. So here, let's look at the data again. This is the lower extreme, and this is the first quartile. So here, this data is pretty close together versus this data out here, which is really far away. So to get from 32 to 18, or 32 to 50, that's 18 units. To get from 8 to 12, that's 4 units. So I can really see how my data is spread out. So the range of this data goes from here to here, so that's 42. But like I said, this distance here is 4, but it still contains those 2.5 numbers versus this distance back here, which is 18, and that contains the 2.5 numbers. So if I'm looking at my data, I've got a lot of this data is kind of clumped up together. These look like they're about the same size, and they go from that's 20, and that's about 10, and that's about 10, so that's pretty consistent. But this data is really close because it's 4, and this data, like I said, is really far. So if this is a fourth of the data, and this between here is a fourth of the data, and this is a fourth of the data, and this is a fourth of the data, that's why we've got these quartiles. So we've got 1/4, 2/4, 3/4, and then that. The last thing that I would like you to write down, and we'll go over this more on Monday, I just want you to get these notes down. The last thing I want you to write down is something called the quartile range. So a range of a set of the data is the difference between the highest and lowest number. So the range of this data is 32. The interquartile range is the distance between Q3 and Q1. So that means that I would subtract 32, which is quartile 3, minus 12, and that's 20. So the interquartile range of this data is 20. And this interquartile range right here accounts for 50% of my data. So that area there is 50% of the data because it is 1/4 and then another fourth, which is 50%, and then this is a fourth and this is a fourth. So make sure you've got all this copied down in your notebook. I'll explain it more on Monday. I hope you had a great day and did a good job on your surface area and volume test, and I will see you, like I said, on Monday. Thanks. Bye.